space propulsion applications, generating higher mission velocities with less reaction mass. Safety nuclear power plants have three unique characteristics that affect their safety as compared to other power plants. Firstly, intensely radioactive materials are present in a nuclear reactor. Their release to the environment could be hazardous. Secondly, the fission products, which make up most of the intensely radioactive substances in the reactor, continue to generate a significant amount of decay heat even after the fission chain reaction has stopped. If the heat cannot be removed from the reactor, the fuel rods may overheat and release radioactive materials. Thirdly, a criticality accident, a rapid increase of the reactor power, is possible in certain reactor designs if the chain reaction cannot be controlled. These three characteristics have to be taken into account when designing nuclear reactors. All modern reactors are designed so that an uncontrolled increase of the reactor power is prevented by natural feedback mechanisms, a concept known as negative void coefficient of reactivity. If the temperature or the amount of steam in the reactor increases, the fission rate inherently decreases. The chain reaction can also be manually stopped by inserting control rods into the reactor core. Emergency core cooling systems, ECCS, can remove the decay heat from the reactor if normal cooling systems fail. If the ECCS fails, multiple physical barriers limit the release of radioactive materials to the environment, even in the case of an accident. The last physical barrier is the large containment building. With a death rate of 0.03 per 2 hours, nuclear power is the second safest energy source per unit of energy generated, after solar power, in terms of mortality when the historical track record is considered. Energy produced by coal, petroleum, natural gas, and hydropower has caused more deaths per unit of energy generated due to air pollution and energy accidents. This is found when comparing the immediate deaths from other energy sources to both the immediate and the latent, or predicted, indirect cancer deaths from nuclear energy accidents. When the direct and indirect fatalities, including fatalities resulting from the mining and air pollution, from nuclear power and fossil fuels are compared, the use of nuclear power has been calculated to have prevented about 1.84 million deaths from air pollution between 1971 and 2009 by reducing the proportion of energy that would otherwise have been generated by fossil fuels. Following the 2011 Fukushima nuclear disaster, it has been estimated that if Japan had never adopted nuclear power, accidents and pollution from coal or gas plants would have caused more lost years of life. Serious impacts of nuclear accidents are often not directly attributable to radiation exposure, but rather social and psychological effects. Evacuation and long-term displacement of affected populations created problems for many people, especially the elderly and hospital patients. Forced evacuation from a nuclear accident may lead to social isolation, anxiety, depression, psychosomatic medical problems, reckless behavior, and suicide. A comprehensive 2005 study on the aftermath of the Chernobyl disaster concluded that the mental health impact is the largest public health problem caused by the accident. Frank N. von Hippel, an American scientist, commented that a disproportionate fear of ionizing radiation, radiophobia, could have long-term psychological effects on the population of contaminated areas following the Fukushima disaster. Some serious nuclear and radiation accidents have occurred. The severity of nuclear accidents is generally classified using the International Nuclear Event Scale, INES, introduced by the International Atomic Energy Agency, IAEA. The scale ranks anomalous events or accidents on a scale from 0, a deviation from normal operation that poses no safety risk, to 7, a major accident with widespread effects. There have been 3 accidents of level 5 or higher in the civilian nuclear power industry, 2 of which, the Chernobyl accident and the Fukushima accident, are ranked at level 7. The first major nuclear accidents were the Kyshtym disaster in the Soviet Union and the Windscale fire in the United Kingdom, both in 1957. The first major accident at a nuclear reactor in the USA occurred in 1961 at the SL-1, a U.S. Army experimental nuclear power reactor at the Idaho National Laboratory. An uncontrolled chain reaction resulted in a steam explosion which killed the 3 crew members and caused a meltdown. Another serious accident happened in 1968 when one of the two liquid metal-cooled reactors on board the Soviet submarine K-27 underwent a fuel element failure, with the emission of gaseous fission products into the surrounding air, resulting in 9 crew fatalities and 83 injuries. The Fukushima Daiichi nuclear accident was caused by the 2011 Tohoku earthquake and tsunami. The accident has not caused any radiation-related deaths, but resulted in radioactive contamination of surrounding areas. The difficult cleanup operation is expected to cost tens of billions of dollars over 40 or more years. The 3 Mile Island accident in 1979 was a smaller scale